In this short video, I just wanted to point out how some of the material discussed in the chapter can really relate to Alaska. The first thing that we're looking at right here is what's called a surface analysis weather map for the northern part of the Pacific. And if you look, you can see the outline of Alaska right here. Here are the Aleutians stretching across here. And then over here we have Russia. And the really important thing to note here is that the northern Pacific is often dominated, particularly in the wintertime, by strong low pressure systems. And these low pressure systems march along that polar front, being impacted by the jet stream, as discussed in the book and in the lecture material as well. They're caused by upper air divergences, and they move along that jet stream, and they're what are responsible for producing a lot of our winter weather, particularly when we get snow or rain, or when we get strong warm winds, the Chinooks that we're familiar with in south central Alaska. You can take a look at the weather maps here. They're in black and white, but you can see that here's sort of a classic mid-latitude cyclone. There's a cold front, because air is of course moving counterclockwise around this low pressure area and pulling cold air in from the north. From the south, air moving counterclockwise is producing a warm front down here, but this particular storm is already partially occluded, which means that the cold front has caught the warm front and the air is all up above. The warm air is all up above, and down below it's cold air. That storm is going to progress and move into the North Pacific as this one has done here, although this one is about the same size and also the same intensity in terms of atmospheric low pressure. This one has already become fully occluded and is actually in the process of dissipating right now. And here's a very weak one over here by Alaska, and you can actually see here there's a little bit of a stationary front with cold air to the north and warm air to the south. There's another low pressure down here as well. And during Alaska's wintertime, but also our fall and our spring as well, these low pressure systems really just march right along the North Pacific, often bringing us a lot of cloudy and stormy weather. In the central part of Alaska and the northern part of Alaska, you'll see that the weather is often dominated by high pressure. So this is a high atmospheric pressure sitting over the upper part of the Yukon Territory in Canada and impacting large parts of Alaska. If you look at some of the details and the temperatures here, you'll see the temperatures are quite low in central Alaska. And in fact, they're relatively low until we hit that stationary front right here. Here, the skies will be clear, although you might get a lot of fog on these days as well, ice fogs and things like that. But you'll also notice that right here you have some very tight pressure gradients, much like we have tight pressure gradients out here. These are going to be producing gale force winds that are going to impact the North Pacific. These are going to be producing very strong winds that are going to be impacting parts of the Wrangell St. Elias Mountains. So here are many of the principles that we've talked about already to this point in class, shown here on this one particular weather map. And these are really easy weather maps to find. Just search online for Alaska surface analysis or something like that. The next thing that I want to show you comes from the Ventus Sky, or that thing that we've looked at before. This shows how orographic precipitation impacts south central Alaska. Here's Anchorage over here. These are the Wrangells and St. Elias Mountains again, but instead of the wind flowing in the sort of east to west fashion as it was doing on that last map, we have winds here flowing very strong from the south towards the north. And this wind took place in early December of 2017, where we had some of the highest snowfalls ever recorded in a single day in parts of south central Alaska, particularly in Thompson Pass near Valdez. But you can see that the precipitation was even more intense over parts of the Wrangels. Huge amounts of snowfalls in the big glaciated areas that we find here. And what's happening is, of course, you have the southern to northerly flow here. And as that air moves upwards, it's got lots of moisture in it because it's been hanging out over the North Pacific. When it reaches these high mountains, what happens is the air loses its ability to hold on to moisture because it's been lifted up and it's cooled adiabatically. And it dumps all that moisture as lots and lots of snow, particularly during the winter time, which is why we have such huge glaciers in this particular part of Alaska. So this is sort of classic orographic precipitation. Look there on the other side of the mountains, the precipitation really falls off. These are drier areas in this case a snow shadow, but it could also be a rain shadow area as well. So these are just a couple things that I wanted to show you about weather in Alaska. There's plenty more that we could look at another time, or if people have some questions about it, feel free to ask me.